Hi, this is Richard C. I'm a math tutor at Wyzant, and I'm answering a calculus question submitted by a student. They want us to use u-substitution to find this integral. So the first thing that I did was I rewrote this. Instead of 1 over 5x plus 14 squared, I just wrote it as a negative exponent just to make it easier to work with. So that's the first step, because really this is so that's what we started with. I'm just rewriting it this way to make it easier. Okay, and now we're going to do u-substitution. When you're doing u-substitution, you always u is usually the more complicated expression here in the integral. So I'm going to make that 5x plus 14, and then du is 5 dx. That should be fairly straightforward. Differentiate with respect to x, du dx. Okay, so that's my 5 dx. So I need a 5 dx because ultimately I want du here. So 5 dx is du. And 5x plus 14 to the negative 2 is just u to the negative 2. To get the 5 out here, I had to compensate by putting a 1/5 in front. So that's all it is. We're just substituting. So substituting 5 dx for du. That this portion here goes here. And then u is what's inside these brackets. So it's u to the negative 1/2. But I needed to put a 1/5 in front because I put the 5 over here. Okay, so now we'll differentiate this. So this is going to be we'll integrate this, find the antiderivative here. So it's going to be u to the negative 1 over negative 1, because when you take the power rule, you're going to get negative 1 times u to the negative 2 over negative 1. So that gives us what we want here. And then we can substitute back in, replacing u now. This u can come down, get negative 5 over u. 1 over negative 5u. And now we just replace u. So 1 over negative 5 times what u was. And that's it. That's your answer. So you could have done this without u-substitution, but it would be kind of a pain in the neck. It's easier to follow it, I think, when you do it this way. But this, I mean, you would end up doing u-substitution. You were just doing it. You'd be doing it in your head and you'd be using chain rule instead of using u-substitution, which I just think is a lot easier when you're dealing with an integral. Okay, so that's all there is to it. And I hope that was helpful to you. And I'll see you next time. Bye-bye.